Ready for another deep dive. Today, we're going to tackle something pretty fundamental in chemistry.
Okay, bring it on.
Equilibrium.
Equilibrium, yeah.
We're going deep into a textbook section on this one.
Awesome.
But
Yeah.
it's not going to be a boring lecture, I promise.
I hope not.
We're going way beyond the
Is it?
basics.
Okay, good.
So think of it like this.
Okay.
Equilibrium is like this delicate balancing act.
Okay, I like that.
But instead of acrobats on a high wire, we're talking molecules.
Molecules, got it.
And the crazy thing is,
What's that?
this concept, it's happening everywhere around us.
Oh, I believe that.
Even in like something as ordinary as a glass of water.
Oh, yeah, that's a great example.
Really?
Yeah, a glass of water. It's like a perfect illustration of equilibrium in action.
I mean, I'm looking at my glass of water right now.
Yeah.
It's not really doing much.
Well, see, that's the thing.
Okay.
What we see as this like still unchanging glass of water,
Yeah.
it's actually a super dynamic system.
What do you mean?
There are these two processes happening at the same time.
Okay.
Evaporation and condensation.
So the water's like disappearing and reappearing?
In a way, yeah.
Okay.
So it's all about perspective.
Perspective.
Like if we look at the glass of water as a whole,
Yeah.
it seems like nothing's changing.
Right.
But if we zoom in, yeah, like to the molecular level, it's a whole different story.
Okay, so at the molecular level,
You got it.
what's happening?
Well, water molecules are constantly escaping from the liquid
Uh-huh.
and becoming vapor.
Oh, so that's the evaporation part.
Exactly.
Makes sense.
But at the same time,
Yeah.
some of those vapor molecules,
Yeah.
they're losing energy and going back into the liquid.
They're like boomeranging back.
You got it. That's condensation.
Okay, I'm starting to get it.
Good.
But if this is happening all the time,
Yeah.
why doesn't my glass just like completely evaporate?
That's the beauty of equilibrium.
Okay, lay it on me.
So at equilibrium,
Yeah.
those two processes we talked about,
Evaporation and condensation.
right, they're happening at the exact same rate.
So for every molecule that's like, peace out, I'm out of here,
Exactly.
another one is coming back.
Yep. It's like a perfect balancing act.
So it's not that things have stopped happening.
Right.
It's that they've reached this state of perfect balance.
Exactly. And this whole idea of dynamic equilibrium,
Dynamic equilibrium.
it applies to tons of chemical and physical processes.
Give me another example.
Think about dissolving salt in water.
Okay.
Eventually, you hit a point where no more salt dissolves, right?
Saturated solution.
But that doesn't mean the salt crystals are just chilling at the bottom.
So something's still going on
At the molecular level, salt's constantly dissolving and crystallizing.
at the same time.
Exactly.
That's wild.
It's all about that microscopic dance happening all the time.
So how do we actually like see this equilibrium?
See it?
Yeah, is there a way to represent it?
Well, one way is through graphs.
Okay, like on a chart.
Yeah, so imagine we plot the concentration of reactants and products over time.
Okay.
Initially, you'd see the reactant concentration going down and the product concentration going up.
Okay.
But eventually those lines, they level off.
So they're flatlining.
Kinda, yeah. It means the concentrations have stabilized.
Equilibrium's been reached.
Bingo.
So the graph is like a snapshot of that whole balancing act.
Precisely. It shows how things settle down, even though there's still that molecular hustle going on.
And that equilibrium, things just stay that way forever.
Not necessarily.
What do you mean?
This equilibrium, it's not static.
It can change.
It can shift.
Oh, interesting.
Think about our water glass example.
Okay.
What happens if we add more water?
Well, I guess there'd be more molecules to evaporate.
Right, you'd throw the balance off.
So it's no longer at equilibrium.
Exactly. But here's the thing.
Yeah.
This whole system, it's dynamic, remember?
Right.
So the rate of evaporation would increase
To compensate.
until a new equilibrium is reached.
So it readjusts.
Exactly.
Huh, so it's like this constant game of catch-up.
You could say that, and this ability to shift.
Yeah.
It's all thanks to this principle called Le Chatelier's principle.
The Chatelier's principle. Okay.
It basically says that if you stress a system at equilibrium,
Stress it out.
yeah, the system will shift to relieve that stress.
So adding more water, that's a stress.
Exactly.
And to chill out,
Right.
the system evaporates more to get back to equilibrium.
And the same principle applies
What's
if
that?
we change temperature or pressure.
Oh, right, like with gas reactions.
Exactly. If you increase the pressure,
Yeah.
the reaction will favor the side with fewer gas molecules.
To like ease the pressure.
Exactly. It's all about finding that balance again.
So equilibrium isn't just some abstract idea.
Okay.
It's like this super active process.
Absolutely. And it's not just in beakers and test tubes either.
Oh, really?
It's everywhere in the natural world.
Like where?
Think about predator-prey relationships in an ecosystem.
Okay.
When there's more prey,
The predator population increases,
right,
but then that leads to less prey.
which then affects the predators.
Exactly. It's this constant dance of shifting balances.
So it's like nature's way of keeping things stable.
Precisely, even when things are constantly changing.
Wow, and I bet it's happening in our bodies too.
All the time.
Yeah.
Think about temperature regulation.
Okay.
Blood sugar levels, pH.
Right?
Our bodies are constantly adjusting to maintain a stable internal environment.
It's like this invisible symphony of equilibrium.
I like that.
So even when things seem totally still and unchanging,
Yeah.
there's this hidden world of activity.
Absolutely. Equilibrium. It's all about finding that balance between opposing forces.
It's amazing how much is going on beneath the surface.
It is. And, as you go about your day,
Yeah.
keep this concept in mind.
I will?
Whether it's a chemical reaction,
Uh-huh.
a biological system,
Yeah.
even social and economic trends.
Oh, wow.
Equilibrium is often at play.
That's a really cool way to think about it. It is, isn't it?
Well, I think that about wraps up our deep dive into equilibrium.
I agree.
So next time you see something that seems unchanging, remember,
What's that?
there just might be this intricate dance of equilibrium happening right under your nose.
Very true.
Thanks for joining us, and keep those brains buzzing.
Always.